All right, we should finish up 1/6 today, so let's see where we left off. We did diagonals, didn't we? Is that what we did?
Yeah.
Just let's review that super quick. If I can find my Polygon tool thing, there it is. All right, so whoa, look at that. All right, so here's Polygon. How many sides is that? 1, 2, 3, 4, 5, 6. So what kind of a? We gave it a name. What do we call it? Hexagon. Very good. Okay, so hexagon. Now, what I just want to talk about right now is a diagonal. Now, we will deal with diagonals. I'll tell you what, before I do the diagonal, let's go this way. I'll go crazy today. I'm feeling wild. All right. So let's talk about it. First of all, if we name this diagonal, this is review. All right, if we name, not the diagonal, if we name the polygon, you can start with any of the letters. It doesn't matter which one you start with, okay? But you have to go in consecutive order. What does that mean? It means the one that's right, what? Next to it, okay? So let's say we start at F, all right? We won't start at A this time. Let's say we start at F, and I wanted to name the polygon. First of all, do we have like a little symbol or anything for polygon? No, we don't. What do? We just write polygon, okay? Or, to tell you the truth, if we want to be more specific about it, we said this was a what kind of gon? Hexagon. So we could say hexagon. Or you could say polygon, that's fine, okay? But if we want to be more specific, you could always say hexagon, all right? And if we're going to name it, we're going to name it with all the vertices, okay? Every one of them. So if there's 5 sides, then how do we name it? With 5 letters, right? If there's 3 sides, we name it with what? 3 letters. If this one right here is a hexagon and there's 6 sides, we name it with what? 6 letters, okay?
It's got 100 sides in it with 100 letters.
That's correct. You're catching on. So if we start at F, all right, it doesn't matter which order we go, okay? So there's so many different variations of what you could call this thing. But if you start at F, you could go this way. So we could call it hexagon what? F, E, D, C, B, A. It's a long name for a thing, okay? Or if you started at F, we could call it hexagon what? F, A, B, C, D, E, and so on. I'm not going to give you all the variations because you can start at any of those points, right, and then go either way as long as they're consecutive, right? You can't do this. Everybody watch. You can't call it hexagon F, C, D, A, B, E. You see that? All right, so you got to go in order, either this way, clockwise, or this way, counterclockwise. We good? All right, one more review thing, and then we'll continue. Let's talk about the diagonals then. Let's start at F. We already got a dot right here at F, so let's start at F. If I draw a straight line from one vertex to the other, but it has to be, they say it's the non-consecutive vertices. So non-consecutive would mean the ones that are not right next to each other. So I'm not going to draw a line segment from F to A or F to E because they would be consecutive vertices. Does that make sense? So they got to go, basically they just have to go through the polygon. And there is something that we're going to do later. I don't think it's this chapter, but later on, I think I mentioned this yesterday, we're going to figure out how, what each of the angle degrees, what each of the measures of these angles actually are, without me giving you any numbers at all. I just say it's a hexagon. You're going to tell me how many degrees is each of these angles, okay? Actually, I would have to say it's a regular hexagon, because there are non-regular hexagons. But if it's a regular hexagon, there's a way to do it. And one of the keys to that is to know how to do diagonals, all right? So I'm so tempted to show you how to do that now, but I'm not going to because we got other stuff to do. So if I start at an F, a diagonal would go from F to B. Is that the only diagonal? No. I could also go from F to what else? C. All right, and what else? F to D. So if I asked you to name, and they could possibly do this, I don't know, maybe they did in the homework. If I asked you to name the diagonals, first of all, what kind of a figure, what kind of a shape or whatever is the diagonal? I'd say what, Ben? No, the diagonal itself. The diagonal itself. Is it a ray? It did start here, but did it keep going through here? Right, it's a line segment, okay? It's a line segment. Because it starts here and it what? And it stops right there. So it's got a length. Go ahead.
Wouldn't the hexagon be considered a plane though?
Well, it's in a plane. It's not a plane itself. It's in a plane. Okay. But yeah, this is a closed figure. That's a good way to put it. Okay. So the diagonal is a line segment. It doesn't keep on going. All right. It starts and it stops. So that means it's a line segment. So obviously, how many diagonals do we have? 3. Okay. I'll tell you what. I'll kind of show you. You can find how much all the angles are. Might as well do this. I'm like so excited about this. Aren't you? Probably not. That's fine. All right. Let's take a look. Somebody mentioned triangles in here. How many triangles are formed by those diagonals? There's 1 right here. There's 2 right here. There's 3 right here. And there's what? 4 right here. Okay? There's 5? There's no others. BFD? No. BFD. Okay. So from this one vertex. Okay. No, that's it. I don't think that it matters how you look at it. If you draw these diagonals, you only have 4 triangles. That's it. Okay. So what do we know? Now, we haven't taught this yet, but I think you already know this because you probably learned this. You probably learned this. Who knows when you learn this? But how many degrees does a triangle have? 180 degrees. Remember that? Probably learned that in elementary school or something, okay? All right. So look, how many triangles are there then? 4. There's 4. So how many degrees altogether in this whole entire hexagon? There's 4 triangles times what? 180. And that is 720. Very good. Okay. Well, you could do it like this. Shh, 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 shh. Listen. You could go, what's 2 times 180? You should be able to do that in your head. It's 360, right? And if you have another 2, that's 4 altogether, right? So what's 360 and 360? 720, okay? Now listen to this. That means all the angles, so angle A, B, C, D, E, F, all those angles add up to what? 720 degrees. Now, if this is a regular hexagon, what could we do to find each individual angle? No. Math. What math can we do? We know they all add up to 720. We know they're all equal to each other. Goes right there. Come on, quick. Do it. Okay. Alex, no. I gave you the chance yesterday. Alex? That's right, okay? Or it's the same number of angles too, isn't it? Okay, everybody see that? If there's 6 sides, open your mouth. Let me see. Did you throw it away for sure? All right. So if there's 6 sides, there's 6 angles. So what would we do with that 720? Divide it by what?
4.
How about 6? Because there's 6 angles. All right. There's 6 angles. So angle A, B, C, D, E, and F, they're all equal to each other, right? So if you divide 720 equally by 6, that's going to give you each individual angle. And what is that?
I don't know.
What's 72 divided by 6? 6 times what is 72?
12.
Thank you. Oh, my word. So it's 120 degrees. So, look, angle A is how many degrees? 120 degrees. Now, this was free of charge, okay? This wasn't in the book. You won't be quizzed, at least on this quiz, on it. We're going to learn that a little bit later, but once we get to it, then you should be good. It was just, I don't know, it was just there, and I thought, I got to teach that since we're here. All right, enough of that. That's a review. I wasted all that time. Well, it's not a waste. I wouldn't call it a waste. All right, let's do this. Let's draw a triangle. You can draw any kind of triangle, I guess. Doesn't matter. Let's draw it like this. And, oops. Let's draw it like this. All right, so there's a nice little triangle right there. And let's name it, we'll call it ABC. Again, this is just kind of definitions. This is just so we know how to talk to each other. When I talk about triangles, we talk about sides and angles and all that kind of stuff. First of all, I don't know if we did this, but we do have a symbol for triangle. All right, so that's the one symbol that we do have. All right, for a polygon. Did we talk about it?
I think it was in the book.
Right. It just looks like a triangle. Okay, just looks like a regular old little triangle. Okay, Don't do an obtuse triangle. Don't do a right triangle. This is actually called an acute triangle. We'll talk about that some other time. So if I was going to name this triangle, we name it just like we would name a polygon. So you start with one of the letters, and then you go in order, okay? So if I started with A, we could call it what?
Triangle ABC.
Triangle ABC, or you could call it triangle what? ACB. Or if you wanted to start at B, you could do that as well, couldn't you? So I would call it what? Triangle BAC or BCA, all right? So I'm just going to call it ABC. 3 for a triangle. Yeah. So triangle's got 3 sides, okay? All right, I know that was exciting, but is there a question on it?
Yeah, I was just
Go ahead.
there is no real order that you can't either way you go.
That's right. That's right. There's no consecutive or, because you can only go this way or this way, right? That's the only way you can go. Whereas if you had a polygon with more than 3 sides, you could, go different ways or whatever. Anyway, enough of that. That's triangle ABC. What do we call the line segments that make up the triangle? We call them the what of the triangle? No, not the vertices. It's the sides of the triangle. The line segments, okay, are the sides of the triangle. The actual point right here of the triangle is called a what? It's a vertex. I think I'm going to sneeze here in a minute, so beware. All right, so I'll try to hold it off. So this is a vertex. Now, watch this. We're going to talk about this word opposite. This is important because you're going to see this in a lot of theorems and postulates. They're going to say the side that's opposite this angle, all right? So, and you're going to see that quite a bit throughout the whole book. So we need to know what that means, okay, when I say opposite. So if I said angle A is opposite, I'll just shorthand it, just go OPP with that, is opposite what side? So here's angle A. What side is opposite angle A? What side? Remember, a side is a line segment. So don't give me an angle as a answer. Line. It's not line BC. It's line segment BC. All right. I know I'm being picky, but it's important. Okay. There's a difference between a line and a line segment. This is a line segment, right? And in a triangle, they stop, don't they? They have endpoints. So it doesn't. It's not never ending. It stops right here, and it stops right here and here. So it's not line BC. It's what? It's line segment BC. So it's opposite line segment BC. And I put a little line segment over top of it. All right. Now, I'm just going to show you this. So here's angle A. If you look, opposite basically means just going across from it. You with me on that? So the one that's opposite does not include the 2 sides that angle A has. You with me? So if I said AB is opposite this angle, it wouldn't be true because it's got A in it, right? AB has A in it. So it's not. It's got to be completely opposite. It's got to be the letters that are not included in that vertex in a triangle.
I know that this wouldn't be possible for something like a triangle, but maybe like another polygon where you could say, so like if you were to
Yeah, we're not going to.
something like a square, you could say, for example, like if you have points A, B, C, and D, you could say there that like angle A is opposite of like angle D because you have.
No, I know what you're saying. I know what you're saying. You're going on too long. Let me stop you. You're absolutely right. Okay, this only deals with triangles. Okay, the opposite is only dealing with triangles. All right, let me say that. Okay, so we're only dealing with a triangle when we talk about opposite. But you're absolutely right. You are correct. So let's do the rest of them. Angle B right here, I'm going to put 2 arcs just to show that it's different. So angle B is opposite what side? Look at it. Just say it. Very good. Line segment AC. All right, so line segment AC. And this is an easy question they could ask you on a homework or a quiz or test, couldn't they? All right, they could just say, they give you a triangle and they say, what side is opposite this angle? All right, so this is stuff that you could see. And then let's do the last one. Angle C right here is opposite what? Line segment AB. Yes, it doesn't matter. Yep, you could call it line segment BA or AB. It does not matter. Now, you could go the other way, too. You could say, what angle is opposite a line segment? So what angle is opposite line segment BC? Well, angle A is, right? Would you agree? You could go both directions right here. All right, so I could say give you a side and say, what is the angle opposite that side? And this is pretty important because, again, we're going to use this later on. Again, they're just making a foundation. They're just setting the foundation for us so we can learn some stuff so that when we actually get to why we need this stuff, we can communicate. When I say this side is opposite this angle, you know exactly what I'm talking about, okay? So this is not the end of it. This is just the beginning, okay? This is just getting us started so that we know later on how to talk about them, all right? All right, let's talk about... Let's do this word. Again, you've probably heard this word before. Perimeter, right? You've heard that before, agreed? All right. So let's say you had a, let's do this. Do you remember what I did to make that a, how did I change the sides of it? Do you remember what I went to up here? Was it transform? Oh, it was shape. Thank you. It was shape. Okay. So watch what I can do. See, it automatically presets to be a hexagon, a six-sided figure, but I could make it a triangle like that. Pretty cool, huh? All right. And I could change that, and I could even I can rotate it. I can do all kinds of stuff like that. Okay. If I could grab it. Come on, come on. There we go. All right. So what if I asked you, listen, what if I asked you to find the perimeter of this triangle? So I'm just going to make some numbers up. Let's say that's 3, that's 5, and this is 9, okay? I'm just making them up. Obviously, it's not to scale. If that's 5, there's no way that's 9, but that's okay. All right, we're good. What if I asked you to find the perimeter of this triangle? What is it asking you to do, Braden? Okay, add them all up. Or find the what? The distance around it. That's exactly right. That's how I usually define perimeter. Now, the book might, it's basically the same thing. The distance around, that's supposed to be a U. That's around, okay? The distance around, and in the book says around a closed figure. All right, a closed figure doesn't have to be a polygon because a closed figure could be a circle. It could be something different like that. Quickly.
I know this isn't totally on topic, but like there is a really crazy formula that you could use if like you have two sides of a triangle, you're trying to find the length of the third one. Oh yeah, that's what I
Yeah, we're gonna do a formula, but I'm not. Listen, there are times we need formulas, but there's times where we don't really need a formula. They give you a formula here. I don't see any reason to like memorize this particular formula, but if you have different lengths for these sides, really the only thing you can do is just add them up. So what would that be? That'd be 3 plus 9 plus 5. What would that be? That would be 17. So the perimeter is 17. What if it was in centimeters? So that's right. Listen, this is what a lot of people have trouble with sometimes. 17 centimeters. Now, eventually, do we do it in? I don't think we do it in this lesson. Eventually, we're going to do like area. Shh, listen to me. Let me talk. Eventually, we're going to do area. Area would be measured in what? Centimeters squared, okay? Some people get mixed up on it. When all you're doing is just adding up a distance, are you going to get a squared out of it? No, you just get centimeters. If I add something up, a 3, a 9, and a 5, your answer is just 17 centimeters. You got it? Or inches, or miles, or yards, or whatever, they give you at the time. Ben. We're not going to worry about area right now. We'll get to it eventually, not now. Go ahead. Yes, go ahead. All right, we will get to area, but not right now. We're just doing perimeter today, all right? So that's how you add stuff together. What if, I'll use that polygon thing again, and we'll stick with the hexagon so I don't have to change it, all right? And let's move it down a little bit and over just a little bit. Okay. What if, now this is a what kind of hexagon? All the sides are equal and all the angles are equal. That's what this program does. Well, it's more than just equilateral. It's equilateral and it's equiangular, which makes it what? Regular. So this is a regular polygon, okay? So here's a little formula. Well, let's do this first. Let's put some I don't know, let's say each side is 5, all right? So every side is 5. So there's a couple ways that you could find the perimeter of this. So if they said find the perimeter, you could just add what? 5 plus 5 plus 5 plus 5 plus 5 plus 5, 6 times. But wouldn't there be a little bit better of a way if it was regular and all the sides are exactly equal to each other? What would it be? 5 times what? 6, that's right. Would you agree? Yeah. Okay, so I could just add them all up, but if they're all the same, so if it's a regular polygon, I could just take how many sides that I have, 6 sides, multiply by how much the length of each side is, 5, and I can get 30. Everybody understands that, right? Okay, that's where multiplication comes from. Multiplication basically is just addition, isn't it? But you're just adding up a whole bunch of the same numbers. That's basically what multiplication is, all right? And so they have a little formula, and they write it like this. P for perimeter equals N for the number of sides, and the S is the length of the side. Okay, I'm not really sure why they use S, but they use that a lot in different books. When I used to teach physics a bunch of years ago, and a lot of times they would use S for the distance. You'd think they use D for distance, but a lot of times books use S for distance. So P represents the what? The perimeter. I'll just shorthand it. N stands for the number of what? Sides. And S is the what? The length of each of the segments, okay? Now, you could sit there and try to memorize that formula. It wouldn't be hard to do. But if you just look at it, you know what to do, don't you? You know you've got to multiply those together, right? How many times you have. Yeah, it's not that big of a deal. So they do give you the formula, so I figured I'd put it on there for you. And there we go. So let's do a couple examples here. Scooch this up out of the way. I'm tired of seeing that boring white color. Let's go to yellow, I think. Can you see that? Oh, that's green. There's yellow right there. Can you see the yellow pretty good? Okay, good. All right, so let's do, I'm just going to draw the triangle out instead of using that polygon thing. All right, so draw this out. This is an example. It's example 4. It's on page 33. I did write that down. And then right here. What kind of triangle does that look like? Obtuse, okay? It doesn't really matter in this problem. And they give it to you in centimeters. I don't even know I'm bothered doing this because it's too easy. Okay, and if it says find the perimeter. I put a question mark there to mean perimeter, okay? So, you need to come in here. Can you get that door? Quick, so he doesn't have to open it. There you go. Do you need some? Yeah, go ahead. So let's take a look. Pretty simple, all right? It's one of the most easy problems you're going to ever do. It says find the perimeter. I put a question mark to mean the perimeter. So what do we do with those two? Do I go 4 times 3 because there's 3 sides and that's my equation? No, this is not a what kind of polygon? It's not a regular polygon. That's right. So I just have to add them up, right? So 4 plus what? 10 plus 8, and what's that? 22. Do I just write 22 and circle it? It's in centimeters, so I put a centimeters right there, okay? Make sure that you label that. All right? Now, I'm going to skip the next one. Look at the next one. You got the book open? They give you a pentagon. Each side is 9 sides. So what if I just told you that verbally? You got a pentagon. Each side is 9 sides. What's the perimeter? 45, exactly. Or whatever, inches or whatever, okay? So I don't need to bother doing that one. That's just a waste of time. All right, now, let's do another type of a figure. It's not a polygon. Tell me what that is. Very good. You guys are so smart. We'll talk about it in a second. Okay, here we go. Let's take a look. Let's talk about a couple things on this. Now, when I click on this, see, this program puts all these dots on there. What do you think that dot right there is in the middle? Very good. It's called the center of the circle. Okay, that's really important. So write that down. Put a dot in the middle and call it the center. And we're going to refer to that quite often. So that's pretty important. Yeah, I didn't even write that on my notes, but that is the center. Let's do this. Let's go different colors so it contrasts against this. Now watch. Shh, stop talking. Just listen to me, okay? This is a little bit new. You may or may not know this. If I connect one point on the circle, I guess you did know it. So if I connect, I wanted to change colors on this. There we go. So if I connect one point on the circle, this is on the circle. What about here? Would that be on the circle? What would it be? It'd be inside the circle or in the circle. This would be what? Outside the circle. Or we could call this the interior of the circle, or we could call this the exterior of the circle. This right here we call a chord. Let's do this. So AB, and it's a line segment because it starts and stops. Okay? So I could call it chord AB. All right? So it's a chord. So a chord doesn't go all the way through. It starts and stops on the circle. Remember, the yellow right here, that's the circle. Inside of here is not on the circle. It's in the circle. This is on the circle. So that's a chord. What if I did this? What if I drew a chord, but it went through the center? You probably know this. Very good. You got it. Okay? So if I drew a chord, we'll call this CD. If I drew a chord, because a diameter is a chord, it starts and stops on the circle. If I draw a chord and it goes through the center, we call that the diameter. So the diameter in this situation is line segment CD. Okay, you with me? Let's do something that you probably, I don't know, maybe you know this, I don't know. What if I connected, and I didn't make a straight line this time, but I actually connected along the circle. Let's just go from AB. So you did know that. Oh, was it? So you looked? Okay, that's great. So this little part right here, see that AB? That's an arc. Now, we have a symbol for that. All right? Right, we write AB. Do you think it matters that we go from A to B or B to A? No, it doesn't make any difference. And then we do this. Watch. We put a little half moon thing over top of it. Okay? And this means arc. Okay? Now, we measure an arc in degrees. We're not going to talk about it too much today, just basically what I said, okay? Later on, we're going to have a whole chapter on circles, and we're going to talk about how to find the measure of that arc. Sam, turn around and pay attention, or you're going to move. So this is measured in degrees. So we would say it's 30-degree arc or 40-degree arc or whatever, okay? What if I asked you the arc from C all the way to D? You probably know that already. If I go from C and I made an arc all the way over to D, how many degrees do you think that is? 180. That's right, because it's half the circle. What's the whole circle? How many degrees is the whole circle? Okay. But again, we're not even getting into that right now. Now, let's talk about a word. Shh. Do you not get it? Well, I'm trying to talk and you keep talking. Okay, stop when I'm talking. Don't say it. I didn't ask. Okay, I did ask. It was rhetorical. Didn't require an answer. Okay, but watch. Let's talk about this. We just finished talking before we went to the circle. What were we talking about? We were talking about starts with a P. Perimeter. Okay. What if I said I started at A and I went the distance? What is the distance from A all the way? Nope. All the way back to A again. No, I said, what is the distance? Okay, degrees is not a measure of distance. Distance is inches, centimeters, feet, yards, miles. That's distance. Okay, what if I went all the way, listen to me, what if I found the distance around the circle? What am I finding? I'm finding the perimeter, correct? But on a circle, they don't just say perimeter of a circle. It's so special that they give it its own name. And they call that the circumference. That's right. Okay, so they call that the circumference of the circle. What does that mean? It basically means it's the perimeter of the circle. Does that make sense? Oh, almost forgot. There's one more thing before I got to circumference I should have done. What about, let's call this O, all right? COD. What if I talked about the distance from from O to D or from O to C? We have a special name for that. Right, that would be called the radius. So from here to here would be called the radius of the circle. So tell me like how much of the radius compared to the diameter, that kind of thing. So the radius is how much of the diameter? It's half the diameter. Or I could go the other way. I could say the diameter is how much of the radius? It's twice. So this is what we write. The diameter is twice the what? The radius. Okay? Or you could do it the other way around if you wanted to. This is how they usually would write it. But you could write that diameter is what? The radius is half the what? The diameter. Okay? You can put big D or little d. It doesn't make any difference. So that's pretty important, and I need to make sure I cover that. Now, radius is something that we're going to talk about right here. We're actually going to have a little formula for the radius, or for the circumference of the circle. And do you remember what it is, Ben? Way off. Circumference, well, it's not circumference times something. The circumference is equal to, you could write it a couple ways. I'm going to show you both ways. You could write it pi times the diameter. Now, what in the world is pi? Yeah, but what is it? What is pi? Let me show you. Listen. Hey, I'm running out of time. Don't make me stop and tell you. Gavin, I've said it over and over. Listen. So turn around and face me when I say that. I shouldn't have to call your name. So what is pi? It's 3.14. But did you ever find out where pi comes from? Why is it 3.14? Okay? Because of this. I used to do this in my classes. It's when I had my own room and I had all my stuff in my own room. But now I'm going from room to room, and so I don't have all my stuff. But pretend we did this. Let's draw another circle here. Okay, so if I had a circle, and let's say it was a cardboard, and that's what I used to have. I used to have a piece of cardboard, and I made a perfect circle, used a compass, right? Made a nice perfect circle out of it. Then I had a piece of string, and guess what I did with that piece of string? I started right here with that piece of string, and guess what I did with it? I wrapped it around the whole entire circle, okay? So I wrapped the string around the circle, and then I stretched it out, and guess what I did with it? I measured it, found out how long it was. So how long would that length, or what word do we use to indicate what the length of that string was? That was the perimeter, or in a circle's case, it would be the circumference, right? So I would actually measure it. I had a meter stick, right? I'd sit there and I'd measure it, and somebody would come up and check it, and I found out the length of it. And then what I did is I took the diameter, all right? So I measured the diameter. I took that string, or I could just take the circle itself because it was cardboard, all right? So watch what I did. I took the diameter right there. Let's just change the color of it. Oops. All right, and then I measured the diameter. What we found out, when I took the circumference measurement and I took the diameter measurement, look what it gave me. It gave me what pi was equal to. Let's do quick little algebra. If I wanted to get pi by itself, pretend that's a variable. How do I get rid of the d? Divide by d. Oops, there it goes. So I divide by the d, and I come over here and divide by d. I don't get it. This is supposed to be honors. We don't do this in honors. This happens all the time in my CP class, but it shouldn't happen in here. So look, this cancels out. So what's pi equal to? It equals to the circumference of the circle divided by the diameter of the circle. And what's really interesting is no matter how big, and I had like several different circle sizes, okay? And we did the same thing to like 3 different circles. We measured the circumference and the diameter, and we divided. Then I took a bigger circle. I measured the circumference of that circle, divided it by its diameter, and I got a number. And then I took a bigger circle, and I did the same exact thing. Guess what was true every single time? Pi always came out, it was close, it wasn't exact, but pi always came out to just a little bit more than what? 3. A little bit more than 3. The 0.14 is a little bit more, okay? So every single time you do that, you could take any circle, no matter how big, find the circumference, find the diameter, and then take the circumference but divided by the diameter, and you're always going to come out with 3 and just a little bit more. If you're really, really, really careful, okay, you might get pretty close to 3.14. I don't know if we ever got exactly 3.14, but that's what it would be, okay? If you had scientific, instruments and stuff like that to measure it, you could do that. In fact, there's computers that have figured out what pi is to like trillions, literally trillions of decimal places. I used to have pi around my room, and it went to like 100 decimal places. But the thing is, did it end? Does that number end? It does not. So there's always a ... What's that ... represent? Just keeps on going, all right? These numbers keep on going. They don't repeat. Listen, they don't repeat, but they keep on going. So that's where we get pi from, okay? Have you ever heard that before? Yeah. Okay, you have? Good. That's awesome. So that's what pi is. Now, what we're going to do is we are going to come up. Yes? Okay. So we said that circumference is equal to pi times diameter, or what did we say the diameter was? The diameter was what? Twice the radius, correct? So we could write circumference equals pi times what? 2r. Or to make it look a little bit nicer and a little bit prettier, we say circumference is equal to 2 pi r. All right? This is the formula that most people remember. This is definitely a formula you have to know. All right? Circumference is 2 pi r, or you could say pi times the diameter. All right? I know I'm running out of time. Real quick example, and then we'll be finished. What if they told you the circumference and you had to find what the radius is? Okay? So let's write down the formula. This is what I would always do. They give you radius. So I'm not going to use pi d, am I? I'm going to use what? 2 pi r. So what are we trying to solve for? We're trying to solve for r. So what do? We divide by 2 pi. Come over here, divide by 2 pi. We said the circumference was the circumference was what? 10. So it's 10 over 2 pi. That's what the radius is. And then you put that in your calculator, okay? Put in your calculator, you get about 1.59. Excuse me. Whew. I knew it was coming. I could tell. And that would be the radius of that circle right there. That's the kind of stuff that you're going to do. All right, here's your homework. It's section 1.6. It's pages 35, 36. I split them up a little bit. So it's 13 to 20. It's 31 to 43. And it's 44. Oh, well, basically it's 31 to 53, let's say. Okay? Because I had broken it up into two different. It's going to be one lesson. All right? So those are the problems right there. 13 to 20 and 31 to 53. And you probably got a lot of those finished last night anyway, didn't you? Okay, so you really don't have all of them to do. Okay. All right, so you should be able to do the rest of them. All right, that's enough. Have a great day. Great weekend.